Okay, so we have now a 3-input variable map. Okay, the first rule in a 3-input variable map is that a group of 4 adjacent cells in line or square combines to yield a single variable. Rule number 2, a group of 2 adjacent cells combines to yield a 2 variable cells. Then the last one, a single cell which cannot be combined represents a 3 variable term. Okay? So for example, we have here a truth table. The inputs are represented by A, B, and C, and the output is represented by X. And the combination values of A, B, C are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Then let's say the output X here is 1, 1, 0, 0, 1, 1, 1, and 1. So this output here again is based on the condition of a particular problem. Let's say this is our representation of the output. So how many cells do we need in order to satisfy a 3-input variable map? So you have 2 to the 3. 3 here represents the number of inputs, no? So you have 8. That is the number of cells that we need in order to satisfy a 3-input variable map, no? So we draw a map. Okay? So we make 8 cells, and these are inputs A, B, and C. So what are the combinational values of inputs A, B, and C? So you have, for A, B, you have 0, 0, 0, 1, 1, 1, 1, 0. Then you have 0, 1. Now take note of this condition here. You have, after 0, 1, you have 1, 1 instead of 1, 0. You take first 1, 1 and then 1, 0. Okay? So this is the arrangement for the 3-input variable map. Okay? So for this particular cell, this has a value of 0, 0 for AB and C, 0. Then you have here 0, 1, 0, 1, 1, 0, 1, 0, 0. Then you have here 0, 0, 1, 0, 1, 1, 1, 1, 1, and then 1, 0, 1. Okay? Then the SOP equivalent map will be this one. So again, this is A, B, C. You have 0, 0, 0, 1, 1, 1, 1, 0, then 0, 1. So you have the product terms will be A bar, B bar, C bar. Then you have A bar, B, C bar. Then you have A, B, C bar. Then you have A, B bar, C bar. Then you have A bar, B bar, C, A bar, B, C, A, B, C, and then you have A, B bar, C. Okay? Then, if you notice that these 4 adjacent cells here, the common is A bar. So, this belongs to A bar or A complement. And this one here, these 4 cells, the common is A. So, this belongs to A. And then, we notice that this one here, what is common is C bar. So, these 4 cells here belongs to C bar. And this one here, what is common is C. So, this 4 cells here belongs to C. How about B? If you notice that here, in this particular area, the common is B. So, this one here, these 4 adjacent cells belongs to B. And then this cell here and this cell here belongs to B bar. Okay? Now, these 4 cells here are adjacent. No? Because if this is a paper, for example, if you fold these 2 sides here, these 2 sides will merge together or will be connected or will be one together. No? So that is why we can say that this particular area here are adjacent. Okay? Now, let us represent the table and derive the simplified logical equation for this particular table. So, we make again a map with 8 cells. So again, this is under A bar, A, B, B bar, B bar, C, and C bar. Okay? So according to our output here, X, you have X is equal to 1 if you have 0, 0, 0. So X is 1. You have 0, 0, 0, the X is 1. Then you have 0, 0, 1. The output is 1. Where's that? 0, 0, 1. The output is 1. And then 1, 0, 0. You have 1, 0, 0. The output is 1. And then 1, 0, 1. 1, 0, 1. The output is 1. Then 1, 1, 0. 1, 1, 0. The output is 1. And then 1, 1, 1. The output is 1. Okay? Then we group them based on our rule. No? So what will be our grouping? So since we have 3 inputs, so that will be 4, 2, 1. Okay? In other words, we have to find first 4 adjacent cells. Okay? Then combine them together into a one group. And then, kung wala na tayo 4 adjacent cells, we go to 2. Okay? And then, we combine the 2 adjacent cells, and then, we have 1. So, in other words, we have to maximize first the number of cells to be grouped so that the output equation will be a simplified logical equation. So, we maximize the number of cells to be grouped. And again, what will be our grouping? 4, 2, then 1. So, in this particular case, we try to find 4 adjacent cells. Okay? So, we have here, these 4 adjacent cells are to be combined into one group. Okay? Now, if you notice that we have 2 cells here, again, we have to maximize the number of cells to be grouped. So, napa by 4 adjacent cells. Okay, that's the question. So, my answer is naa pa. Where is that? This particular area. This one and this one. As I've said earlier, once you fold this side here, just like a paper, for example, mag-abot di silang duha, kanina side and kanina side. So in other words, they are adjacent and they belong to the complement. Okay? So, in this case, what will be our equation? So for this one, this belongs to A. Right? Okay, this one, this group of adjacent cells belongs to A. And this, another 4 groups belongs to B, complement. Okay? So that will be our variable terms. So what will be our equation? The equation will be A plus B complement is equal to X. That will be our equation. So logically, we can represent that with an OR gate. We have inputs A and then input B complemented. So that becomes your X. Okay?